Hello and good morning, good afternoon, and good evening to you out there from wherever you are joining us across the globe. It's another beautiful day for us to learn physics. We thank the Lord God Almighty who has given us the gift of life and the health. Without life, without health, you wouldn't be here on this platform. You can't learn if you are sick. So we appreciate God who has given us the health. Today is the 30th day of December 2021. We have one more day. And 2023. Today is 30th day of December 2023. This is the second to the last day. After one more day, 2023 is going to be over. So, my name is Samuel Anekan, and I'm going to be your tutor. I'm going to be your host. So, this is our series on density. This is our series on density, which has been going on. This is actually lecture 8, lesson 8. We've done lesson 1, lesson 2, lesson 3, up to lesson 7. In case you missed out, just make sure you go over those lessons so you have a better understanding of the lesson, of the topic we are actually doing. We've looked at density, we've looked at relative density, we've looked at upthrust, we've looked at the archimedes principle. So today we'll be looking at the principle of flotation. We'll be looking at the principle of flotation. But before we continue, if you want to get the best from this lesson, there are things you need to get. You need to get a pen. You need to get a pen and paper, so that as we're working, you'll be taking down your notes. And I will even advise you, it's better you get a note and dedicate it to these lessons that we are running, for you to have the best. So, like I said, get your pen and your paper. And before we continue, in case you are not subscribed to this channel, go ahead and hit the subscribe button, and not just the subscribe button alone. Make sure you click the like, because I'm assured that you are going to actually enjoy this lesson. And at the end of the day, be ready to drop your comments. Click on the bell icon and set it to all, so that you always be notified whenever I upload a new video. So, like I said, we'll be looking at the principle of flotation. What is flotation? What makes body float? Sometimes you drop an object inside a liquid, let's say inside water, and it's going to sink. Or in some instance, it won't sink, it will float. There are instances whereby a certain part will be beneath the water, a certain part will be above, it will still float. So what causes that? What makes the body sink and what makes it float? One thing that makes a body to float or sink is the density of that body compared to the density of the liquid in which it is being submerged. If the density of a body is smaller than the density of the liquid into which it is put into, that body is going to float. But if the density of that body is more, it's going to sink. Okay, like I said, it's going to do what? It's going to sink. Sometimes you have a greater part will sink, then a greater proportion of the volume of that body is going to be submerged, while a little portion will be above the liquid. For other bodies, the reverse will be the case. A greater portion will be above the liquid, then a little part will be below. So what actually causes these things? These things are all based on the principle of flotation. So like I said, that a body only floats when its density is less than the density of the fluid into which it is being submerged. Now, we have spoken about upthrust, the force that acts upon body submerged in a fluid. The more the volume of that body submerged, the more will be the upthrust. The upthrust increases. For instance, now, this is a body now. This is a body of liquid. Let's say this is a body of water now. This was initially when the body was being submerged. Here, the density, the upthrust is going to be lower compared to when here we have more volume being submerged. Here we have almost the entire volume. We're going to have more upthrust here compared to here. So upthrust increases when you have more of the body being actually submerged. Upthrust increases with the volume of the body that is being submerged. So the more a body is being submerged, the more of a body that is being submerged, the more upthrust will be act on that body. Now, if it gets to a point whereby before the body is completely submerged, the upthrust is equal to the weight of that body. Like now, let's take it now. If let's assume that this body, the weight is 10 Newton, and I now submerge it. As I'm submerging, let's assume at this point that the upthrust is 2 Newton. Okay, let's assume that at this point the upthrust is 4 Newton. Then we immerse it further, the body sinks further, and maybe at this level the upthrust acting is now 10 Newton. So as this thing is submerged further, and at this point the upthrust is now 10 Newton. Now the weight of this body acting down is 10 Newton. This body is not going to sink further inside the liquid. It's not going to go down further. At this point, this body is going to float, because before it sinks completely, the upthrust at this level is now equal to the weight of the body. So this body is going to float. So a body only floats when the upthrust is equal to the weight of that body before it actually sinks. Okay, so that is it here. Let's just look at it. At this point, the body was just being submerged. The upthrust was 4 Newton. The weight of the body is 10 Newton. So since the upthrust is less than the weight of the body, it's going to sink further. It's going to enter the liquid. More of it is going to enter the liquid. But when it enters to a point where the upthrust is now equal to his weight, then this body is going to float. It won't sink any further. It will remain at this level. Even if you forcefully push it down, it will rise up again and float at this level. So that is it with upthrust. That is it with flotation. So we are going to look at the principle of flotation. We are going to look at the principle of flotation. In our previous lesson, we looked at Archimedes' principle. That was in lesson 6 and lesson 7. We looked at Archimedes' principle. So in this one, we will be looking at the principle of flotation. So I'm going to write down the principle, state the principle, and explain the principle. That principle is what governs floating bodies, floating of ships, floating of balloons, things that float, whether in the air, whether in liquid. So they are all governed by the principle of flotation. So you can take this down. This is not the principle. For a body to float, the upthrust on the body must be equal to the weight of the body. For a body to float, the upthrust on that body must be equal to the weight of the body. So I'm going to write down the principle of flotation. So this is the principle of flotation. The principle of flotation states that a floating body always displaces its own weight of the fluid that supports it, or its own weight of the fluid in which it floats. Or the principle of flotation states that an object will float in a fluid when the upthrust you exerted upon it by the fluid in which it floats equals the weight W of the object. So what are we saying? The first one, the principle of flotation, states that a floating body always displaces its own weight of the fluid that supports it. So a body can only float when it has displaced a weight of fluid that is equal to its weight. When the weight of fluid actually displaced is the upthrust. The weight of fluid that is displaced is what? The upthrust. From Archimedes' principle. Archimedes' principle states that when a body is wholly or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of fluid displaced. Okay, so the upthrust, the liquid provides the upthrust from a Newton's principle, and that upthrust is equal to the weight of that displaced liquid. Now for a body to float from this principle of flotation, the weight of fluid displaced must be equal to the weight of the body that is floating. The body will only float when that weight of fluid displaced, which is the upthrust, is equal to the weight of the body that is floating. So for a body to float, it must displace a weight of fluid that is equal to its own weight. That weight of fluid is actually the upthrust that it has displaced, is the upthrust. That upthrust must be equal to its weight. If not, it will not float. So an object will float in liquid when the upthrust U exerted upon it by the fluid in which it floats equals the weight of the body. These are statements just stated in different ways. Okay, so you must actually, it's not about cramming, understand the statement. Make sure you understand it. You understand Archimedes' principle, you understand the principle of flotation, so that you can always be able to make use of it in calculations. Okay, so we're going to go further. So from the principle of flotation, the statement in the principle of flotation implies that when the body floats in a fluid, the weight of fluid that is displaced is equal to the weight of the floating body. That is just the implication. The weight of fluid displaced is equal to the weight of the floating body. Okay, so if upthrust is, when upthrust is equal to the weight of the body, that is the mass in the fluid, the body is going to float. Okay, but if the weight of the body is greater than upthrust, the body is going to sink. The body is going to do what? It's going to sink. If the weight of the body, that is a mass in the fluid, is far greater than the upthrust, the body is going to sink. Okay, there are various points for us to note from the principle of flotation. The first point to note is that a body displaces a volume of fluid that is less than its volume for it to float on that liquid. A body displaces a volume of liquid less than its own volume for it to be able to float on that liquid. How? Take for instance that this water now. Then I now have maybe wood, a rectangular box of wood. Then when this portion of the wood is submerged in water, it doesn't go down anymore, it begins to float. Now this volume of this part here that let me shade it. The volume of water that is displaced is just equal to this alone, while the volume of the box, this box, is everything here from here to here. The volume of the box is larger than the volume of water it has displaced for it to be able to float. Okay, so if everything is, the entire box enters the water, if this box sinks inside the water, let's assume that we have a metallic plate which actually going to sink. In that case, it will displace its entire volume. It's not going to float. Once the entire volume of an object is displaced, that object is going to sink in that liquid. We should have that in mind. But for a body, an object to float in a liquid, the volume of liquid displaced is going to be smaller than the volume of that object. So this is a box of wood now. Let's assume it gets to this point. The volume of water displaced is just from this point to this place to this place. While the volume of the entire box is everything. So the volume of displaced liquid is actually less than the volume of the object, the box. But the weight of this liquid is going to be equal to the weight of this box. When you measure the weight of this liquid that has been displaced, it must be equal to the weight of the box. Okay, the weight of the displaced liquid, this portion of liquid, is going to be equal. When you measure the weight of this volume of liquid, the weight will be equal to the weight of the box itself. But the volume will not be equal. The volume of the liquid will be smaller than the volume of the object, the volume of the box. So that is one point to note. So we're going to go to the second one. So, for the second one, the weight of the liquid displaced is equal to the weight of the floating body. I've already explained this one when I was explaining the first one. The weight of the liquid that is displaced is equal to the weight of the floating body. I've explained this one. So if you measure the weight of that volume of liquid displaced, it's going to be equal to the weight of that object that is floating. So that is the second point to note. We'll move to the third. So the third point to note is that a body will only float in a liquid of density, of greater density than its own density. So a body will float when its density of that body is less than the density of the liquid in which it is floating. If the density of that body is higher than the density of the liquid, it's going to sink. So it can only float when its own density is smaller than the density of the liquid in which it is floating. So let's recount the 3 points. The first one was that the volume of liquid displaced must be smaller than the volume of the object that is floating. Then the second one is that the weight of the floating object will be equal to the weight of displaced liquid. Then the last one is that the density of the liquid will be less than the density of the floating body, the floating object. Those are the 3 points you have to take note of. Okay. Now, why do ships float? Isn't that amazing? Ships are made of steel and iron. A small coin made of iron will sink in water, but a large ship made of steel or iron floats. Why? Why is it so? Why is it so? It's actually amazing. So Why is actually so? It's actually the design of the ship, the way the ship is designed. Unlike the coin, that the coin or even a bar of iron or a bar of steel. Let's look at something like this. Something of this nature. Of iron or steel. That everything is solid, as in there is no hole inside. Everything is, this is completely solid iron. This is solid steel. There is no hollow. There is no space. If you put this inside water, it's going to sink to the bottom, because the density of this iron bar is actually greater than the density of water. But I'm going to explain with respect to the ship. Why is it that a ship is able to float? It's the way this ship is designed. The ship is not actually, you have a ship this way and all that. The entire ship is not made of solid iron. There are spaces, there are gaps inside the ship. The ship is actually hollow, designed in such a way that it will displace a high volume of water. The ship is designed in such a way that it can actually displace a high volume of water compared to the volume of material that is used to make the volume of steel or iron that is used to make the ship. The ship has been designed in such a way that it will actually be able to displace a greater volume of water compared to the volume of steel or iron that is used in fabricating the ship, in making the ship. So, like I was saying, that the ship is designed in such a way that the volume of water is going to displace will be larger than the volume of material used in making the volume of material, the volume of iron or steel that is used in making that ship. So you have the mass of material that is used. Then the volume of that material is not the volume we're using. It's the volume of water that it actually displaces, which is far larger than the volume of material and is used. So that is what we are using to calculate the average, the density of the ship. The volume of water it actually displaces is what we are going to use, which is more than the volume of material that is used in making the ship. So at the end of the day, with that large volume of water it displaces, which we are using, at the end of the day, if you calculate the average density of the ship, the mass of the material divided by the volume of water it displaces, this is large. The average density of the ship becomes smaller than the density of water. If you are using the volume of material that we use to construct the ship, the density of the ship, this volume is small, so the density of the ship is going to be higher than the density of water. But now using a large value now, will actually reduce the density. It's just like you have 20 kilogram over 2 cubic meters, and you have 20 kilogram over 10 cubic meters. This is density. Here you have a small volume, then you are going to have 10 here, 10 kilogram per cubic meters for the density. Here 20 divided by 10, a larger volume, you're going to have 2. Density here decreases. So due to the design of the ship, whereby it's being designed in such a way that it has a large volume, it can displace a large volume of water. That volume is what we use in calculating the average density of the ship. So which gives the ship an average density that is smaller compared to the density of water. So that is why the ship is actually able to float. And another thing is that ships are actually hollow objects. They contain air, so they are not as in solid mass throughout iron from beginning to end. There are space gaps hollow filled with air. So when you mix density of the small metals involved and density of a lot of air, at the end of the day, the average density is smaller. The average density of the ship is smaller than the density of the water in which it is floating. So that is why the ship is actually able to float. So right now, we'll be looking at the factors affecting flotation of a body. We'll look at the factors affecting flotation of a body right now. Those are the things we'll be looking at. The factors that affect flotation of a body. So what are the factors affecting the flotation of a body? One is the volume of the fluid supporting the floating object. The volume of the fluid supporting the floating object. The volume of the fluid that is supporting the floating object must be more than the volume of the floating object. Two, the density of the liquid. The density of the liquid must be more than the density of that object that is floating, or its average density. Then the volume and weight of the object floating on the liquid. The volume and weight of the object that is floating on the liquid. Those are the factors that affect the flotation of a body. So at this point, we've looked at why bodies float. We've looked at ships, why ships float. That even if those ships are made of steel, they're made of iron, and the density of steel and iron is actually far greater than the density of water, ships still float. I've actually explained the reason to you right now, and we've looked at the factors that affect flotation. We've looked at points to note from the principle of flotation. So I'm going to call it a day right now, and I believe you've actually enjoyed the lecture. So in our next lesson, we are going to solve some calculation that involves flotation. So at this point, if you're not subscribed to this channel, please go ahead and hit the subscribe button, and also press the like button as well, and drop your comment, and it's the bell icon so that you always be notified when we upload a new video. Thank you for joining us. Watch out for lesson 9, where we're going to solve calculations of the principle of flotation.